imagine that we connect the HID ballast directly to where the halogen bulb is connected. Some vehicles might be able to power up the HID system normally, without problems at install time. Most probably, it will not last long. The inrush of current can be up to 15 amps per ballast, compared to 7 amps, when using halogen. The factory design parameters for halogen headlight circuit is usually 7 amps, and 4.5 amps continuous load. So over time, connectors, multifunction switch, headlight switch, wiring, and fuse holders will slowly degrade because of heat buildup. These components are very time-consuming to replace because they are usually well hidden behind dashboards and other wiring looms. These parts are also very expensive. How can you ensure not to fry the car's internal headlight harness? During normal HID operation, you use only 40 watts, 35 watts, to run the bulb plus 5 watts in heat losses in the ballast instead of the 55 watts that the halogen bulb uses. This is less, but during HID cold startup and for the first several seconds during warm-up, the HID system can draw up to triple the normal operating power to run the igniter circuit. As the bulb warms up, the current draw then goes to the normal running level. By powering the ballast through a relay, straight from the battery to the HID ballast, the heavy load is removed from the stock headlight circuit. Triggering the relay only requires 0.1 amps, so stock headlamp circuit has no problem powering that. A relay is just a remotely mounted heavy-duty switch, and the trigger power that goes to it just draws a small amount of current through the headlight switch to run an electromagnet that mechanically closes the contacts inside the relay. This in turn hooks battery power straight to the HID ballast power terminal. This ensures that you won't ever overdrive the ratings of your vehicle's harness. Does triggering relays directly from headlight connector harm the headlight switch? The answer is yes. Activating relays is done by connecting voltage to a coil, which in turn creates a magnetic field. When voltage is removed from the relay, the energy that is stored in the coil collapses and will send current the other way by increasing voltage to several hundred volts. A small arc will be visible between the contact elements of the headlight switch. Over time, the switch will only work intermittently and will eventually fail. That's why a serial diode is essential to protect the headlight switch. Here's the current path to a properly connected HID retrofit electrical wiring. The heart of most of the electrical work is at the HID relay. The relay, the most common is a Bosch type, has 5 terminals, of which 4 are of interest to you. Terminals 84 and 85, sometimes labeled 85 and 86, is the relay coil. Remember to install an inline diode between these 2 terminals. Most newer relays have this diode internally. As we've said before, the diode protects the headlight switch from damage due to arcing. Shown in this video, terminal 84 is connected to ground. You may connect either of the relay coil terminals to ground. This is the activation coil for the relay. The other terminal, in our case, terminal 85, connects to the output of the headlight switch or right at the original halogen wires in the engine bay. You can connect both terminals 84 and 85 straight to the original headlight switch. The relay will only draw about 0.1 amps, well below the typical 5 nominal amps seen from a halogen system. Then, terminal 30 of the relay is connected right to battery positive through a fuse. You can use a 20 amp fuse for the HID system. Do not connect terminal 30, the center relay terminal, to the original headlight power circuit. The current load is different and will cause problems. Terminal 87 or 87A, which is the relay output, is then connected to the HID ballast. The nominal power rating for most universal Bosch relays is 30 to 50 amps. More than enough for this application. The ballast itself needs to be connected to chassis ground. Do not accept any other type of ground. The ballast circuit needs to cope with the ups and downs of electrical current in HID systems. Finally, the high voltage output of the HID ballast connects to the bulb itself. These are the two wires you must watch out for due to the high voltage in them when operational. So current flows from terminal 84 through the relay coil and terminal 85, thereby activating the relay. Then, the electrical current flows from the ballast chassis ground terminal through the ballast and relay, then through terminal 30 of the relay. Remember, current flows from negative to positive. Finally, with the relay activated, current flows also from the ballast ground through the ballast and through one of the high voltage wires. Current flows to the HID bulb, creating the arch, then back through the other high voltage wire, seen here in red. Current then keeps going through the ballast and to terminal 87 of the relay, where it then goes through the relay and back down to terminal 30. This current flow analysis points out that terminals 30 of the relay and the ballast ground carry the heaviest current load. So these two circuit points are very important. They'll determine if your HID retrofit installation will perform properly for years to come.